Welcome back. Today we're going to be talking about naming ionic compounds. In our last lesson, we talked through the differences between, I've got this periodic table inserted there, between ionic and molecular compounds, where an ionic compound is a compound that forms between a metal and a non-metal, where a molecular compound is a compound that is formed between two non-metals. Today we're going to be talking about how we name ionic compounds. Ionic compounds contain two different ions. The one ion, the metal ion, is called a cation. Let me just change the right font there. Remember that a cation is our positively charged ion. And I remember that it's positively charged because I like cats. I think cats are a positive thing. And our negatively charged ion is called an anion. I remember it's negatively charged because the word anion kind of sounds like onion, and onion makes me cry. Here's a picture of an ionic compound. This is called sodium chloride. We name these compounds based on their ions. The positive ion, the cation, is called the sodium ion, and the negative ion is called the chloride ion. Ionic compounds are solids at standard ambient temperature and pressure, and they form solutions that conduct electricity. Remember that ionic compounds form, or ions in general form, because all atoms want to have complete valence shells. A complete valence shell means that it is full of electrons. If you look here, this is the Bohr diagram for a sodium atom. It's got 2 electrons in the first energy shell, 8 in the second, and 1 in the third. When the sodium atom becomes a sodium ion, it gets rid of an electron so that its outermost shell is full. Because it's lost an electron, and electrons have a negative charge, the sodium is left with a positive charge. It has 11 protons and 10 electrons, so overall it has a positive 1 charge. The chloride is a chlorine atom which has gained another electron so that its outer valence shell is full. If we were to add these up, it's got 2, 8, that brings us to 10, another 8, 18 electrons, and 17 protons. That's the atomic number for chlorine, which gives it a negative 1 charge because it has more electrons than protons. This chloride ion here is our anion, and this sodium ion here is our cation. Ionic compounds will always start with a metal ion or an ammonium ion. More on that in the next lesson. Ammonium, you can find ammonium in the table of polyatomic ions. Just so you know what it is, we'll write it down here. Ammonium is NH4+. You'll always start an ionic compound with a metal ion or an ammonium ion. So if you see a compound that's written out for you and it starts with either a metal or this NH4+, then you know it's an ionic compound, not a molecular compound. We're going to start with binary compounds. These are going to be compounds composed of a metal and a non-metal. Just a single, this is a metal cation and a non-metal. Binary means 2. What you're going to see here is that we're just going to have, so binary, this prefix bi means 2. So you're just going to have 2 types of elements. We're going to have 2 types of elements. There'll be the metal and there'll be the non-metal. When you name these, you just write the names of the ions. So you write the name of the metal ion first. Remember, that's our cation. But you can drop the word ion when it's in a compound. And then you write the name of the non-metal, which is our anion, last. And remember that the anion name has to be changed to "-ide". So for example, I'm going to do the parts of the name that come from each piece in their colors. So in red here, this Na, if we go to our periodic table and we find Na, that is sodium. If you want to know the names of the ions, it's actually given to you on your periodic table. Na plus here is also just called sodium. It's our sodium ion. Remember that the cation name doesn't change from the element name. So if we're naming this compound, it's just going to be sodium. And then we find Cl on the periodic table. Cl is chlorine, but when it's in its ion form, we have to change the ending to "ide," which on your periodic table is already given to you. This is it as an atom, chlorine. As an ion, we call it chloride. And so if we combine sodium and chlorine, we get sodium chloride. And this tells us this is our ionic compound. This next one as well. You just need to search for the elements on the periodic table and then name them in their ion forms. Mg is magnesium. As an ion, it's also called magnesium. Remember that cations don't change their name from the element form when they become cations. So this is just magnesium. And then O is for oxygen. I'm going to show you on the table again. If you find O is number 8. That's oxygen. But as an anion, we call it oxide. So this isn't just magnesium oxygen. This is magnesium oxide. And this "ide" ending is important because it tells us that this magnesium and this oxygen are attached together in this compound. There's some good practice here. If you want to pause the video right now and try filling in these practice names. Again, you're just naming the metal first, the cation first, and then you're naming the anion. Something I want to point out here. The little subscripts here don't affect the name. I'm actually going to make a note here because we haven't outlined that here. I'm just going to write here that the subscript doesn't affect the name. So if you're looking here, we do know that there are 2 rubidiums, that's Rb. If you're back on your periodic table, you can find Rb in group number 1, it's number 37. Rubidium, Rb+, that's also the name of the ion. But even though there's 2 of them, it doesn't change the name we give to it. We don't call it 2-rubidium or dirubidium, it's just rubidium. So this is just rubidium. And then the O in its ion form is oxide as well. The next one as well, we don't change the name for the little subscript here. So we're just going to find what Li is. On your periodic table, if you find Li, you'll find that's lithium. And if you find N, that's nitrogen. And if we look on our periodic table, when nitrogen becomes an anion, we change the ending to "ide, so it becomes nitride. Sometimes it's hard to know where that "ide" goes. And so if you didn't have this written here, you might write nitrogide. But because our Science 10 periodic table has the ions written for you, you should know to look here to make sure you're naming it correctly. So nitrogen, when it's in an ionic compound and it's become an ion, an anion, we call it nitride. Went 1 page too far, going back down to the bottom here. This is lithium nitride. Gonna jump to our next page. That's working from the formula to the name. You're just naming what's in it. But we can also go the other way. We can be given a name for an ionic compound, and then we have to change that into a formula. In order to build these formulas, the important note here is that all ionic compounds have to have a net charge of 0. What that means is that the positive charge from the cations has to equal the negative charge. The positive charge must equal the negative charge. For sodium chloride, this happens pretty easily because sodium brings a +1 charge, chloride brings a -1 charge, so the net charge is 0. Because the compound overall is neutral, neutral means that the charge is 0. In this case, I know we brought up the word neutral in the last lesson to mean that it's not an acid or a base. In this context, the word neutral means that it is uncharged. No net charge. We don't have to put any charges on the compound. Yes, the sodium in here is Na+, and the chloride is Cl-, but we don't write the compound as Na+, Cl- because these charges cancel out, so the compound is written as NaCl. This is just going to say the same thing that we've already said. Each formula unit of an ionic compound contains the same amount of positive charge and negative charge, which means those charges will cancel out to make a net charge of 0. Use the lowest common multiple between the charges to determine the number of each ion in the formula unit. Let's work through this. We're going to do a couple examples here. When I get an ionic compound name, I want to make sure that I know what those ions look like. So our first one here is barium fluoride. The first thing I'm going to do is find barium on my periodic table. I'll go back a couple pages. Barium, because it's the first one, I already know that it's a metal, so I should be looking to the left of the staircase. The staircase is cut off on this one because I've got the periodic table on 2 pages, but this is your staircase here. I'm going to be looking for my cation to the left of the staircase. Takes a while to get used to searching these, but barium here is down number 56. Barium is Ba2+. And I know the next one is fluoride, which is over here, F-. Just to show you where I found those on the table. Barium fluoride. So I'm going to write down what I've been given. I know that I have barium ion, which is Ba2+, and I also have fluoride ion, which is F-. If you're taking a look here, you can see that we do not have enough negative charge to cancel out the positive charge. If I was going to add these together, I've got 2 positives and 1 negative, so overall I would have an unbalance of charges. I would have 1 positive charge overall. So to change this, we can add a second fluoride. If I have 2 fluorides, now my total positive charge is 2+. Let's make a little legend here. This is my charge. I've got 2+, and my total negative charge, if I have 2 fluorides, is 2-, which means our total charge, if I add those together, is going to be 0. I want my ionic compound to have a net charge of 0. This phrase here, the lowest common multiple between the charges, use the lowest common multiple between the charges. If I'm looking at these charges, this has got a 2+, this has got a 1-. The lowest common multiple is the smallest number that both 1 and 2 can multiply into, and that answer will be 2. 2 times 1 gives me 2. 1 barium gives me a 2+ charge. And 1 times 2 will also give me 2. So 2 fluorides gives me a 2- charge. When I write this as a formula, then I put a subscript to indicate how many of each ion I have. I only have 1 barium, so there's no subscript needed. However, I have 2 fluorides, so I put the subscript 2. This 2 indicates that I have 2 fluorides, and the no subscript here indicates I have 1 barium. There's no charges on this formula because the charges cancel out. I've got a 2 plus and a 2 minus. You can put the state of matter as solid because all of these ionic compounds will be solid at standard ambient temperature and pressure, or room temperature, if you will. If you take a look over here at the next one, example 2, calcium sulfide, we'll work through this one as well. The first name in the formula is our cation. The second name is our anion. Calcium, if I go back to my periodic table, which I'm not going to do, but you are welcome to do so just so that you get the feel for it. Calcium, you'll find it's number 20. Calcium has a 2 plus charge. And sulfide it's got a 2 minus charge. Actually, I'll go back to show you sulfide. Remember, I'm looking for the anion name. So sulfide here, I'm going to not find it as the element sulfur. Because it's in its anion form, I'll find it on the bottom of its box. So sulfide is here. It's got a 2 minus charge. Now I'm asking myself the question, how many of each of these do I need to cancel? But if you're looking here, we already have 2 plus and 2 minus. So the total charge, our positive charge, is 2 plus. So I'm going to go down here, total charge. Positive charge is 2 plus, and the negative charge is 2 negative, and so they already cancel. So our total charge, if we add those together, is already 0, which is what we want it to be. So we only need 1 calcium and 1 sulfide to balance the charges so that the positive charge equals the negative charge. If we're writing the formula for calcium sulfide, then we would write calcium and then sulfide. No charges within the compound because those charges have canceled out, and again, we can make it solid. Some of you might have learned the trick that you can take the charge from the cation and make it the subscript on the anion. If we go back to barium fluoride here, that would be taking this 2, and this 2 plus charge becomes our subscript of 2 on the fluoride, and this 1 negative charge, that 1, becomes the subscript on the barium. This is an example where that trick doesn't work, because saying calcium with a little 2 and sulfide with a little 2, this is incorrect. We always want to make sure that our ionic compounds are in their simplest possible form. While this is somewhat true, because 2 calciums would have a 4 plus charge and 2 sulfides would have a 4 negative charge, and those would balance out, the simplest form for calcium sulfide is just 1 calcium and 1 sulfide. And because that's our simplest form, that's the answer that we're looking for. Example 3 is a little bit trickier. Magnesium nitride. Magnesium nitride. If you're looking at your periodic table, you do some searching. Magnesium's number 12. Magnesium as a cation is Mg2+. Nitride, nitrogen's number 7, and nitride, the anion form, is 3-. These numbers don't easily cancel out. Our starting charge for our negatives is 3-, and our starting charge for our positives is 2+. If we were going to add these together, we would have an overall net charge of -1. So we need more positives. We can only add positives by adding magnesiums. If I add a second magnesium, now my overall charge is 4+. My negative charge is 3-, so my net charge would be +1. So we've added too many positives. Let's add another negative. If I add another nitride here, now I have 6 negative and 4 positive. So I need to add another positive 2 plus for magnesium in order to cancel out. If I add this all up, my total positive charge is 6 plus, and my total negative charge is 6 minus, which would bring us to a net charge of 0, which is what we want. Another way to think about this is, what is the lowest common multiple between 2 and 3? The smallest number that both 2 and 3 can multiply to get is 6. If you have 3 plus 2's, you will get to 6 positive. And if you have 2 negative 3's, you will get to 6 negative. I'm just going to put these in brackets to separate them from this addition sign where I'm adding the charges together. When I put together the formula for magnesium nitride, I don't want to write magnesium 3 times, so I go magnesium with this subscript 3, it's a pretty bad 3, and nitride with the subscript 2. This 2 is telling me I have 2 nitrides, and this 3 is telling me I have 3 magnesium ions. This is an ionic compound, so it will be solid. And that is our end. Remember, there's no charges on these. Yes, each one is charged, but when we match them together, the charges have canceled. So the compound itself has a net charge of 0 because I've got 6 negative charges here and 6 positive charges here. So overall, it's canceled out. Here's a lot of good practice. What they've written here is not the anion form, so you're going to have to find the element and then change it into the anion. So if you're looking, well, I'm just going to pick E because we haven't done something with phosphorus yet. So barium, you'll have to find barium. When it forms a cation, barium is going to be Ba2+. And then phosphorus. Phosphorus, when it forms an anion, is going to be, I'm going to go back to your periodic table here, phosphide, which is P3-. Barium and phosphorus, phosphide is going to be P3-. So when those two come together, you're going to get P3-. If you're balancing these charges, this is going to be very similar to the magnesium nitride that we just did. We're going to need 3 bariums. So we're going to need 3 times our 2+ charge to get us to a 6+ charge. And I'm going to need 2 phosphoruses, 2 times my 3 negative charge to get me to my 6- charge. And so when I build this into a compound, I need 3 bariums, it gets the subscript 3, and I need 2 phosphides, it gets the subscript 2. This is my 3 from right here. I'll put a little green underline. This 3 subscript is the number of times I've multiplied my barium ion. So I've got 3 barium ions. And then this 2 subscript is the number of times that I have multiplied my phosphide ion. So I've got 2 phosphide ions. I'm just going to put brackets around these charges to show that's what I'm multiplying. If I'm going to name this, it's not called barium phosphorus. Remember that this anion gets the ending "ide", so the name of this compound is barium phosphide. And you can find those anion names in the bottom of the nonmetals on your periodic table. So phosphide is written right there. There's a lot of good practice here for writing the formulas and just breaking down these names for these different compounds. Pause the video and give them a try. And then I'm just going to go over tungsten oxide. This is just a last ending for this lesson. If you've had a chance to try them all, we're just going to go through tungsten oxide. Tungsten might take a little while to find on the periodic table because you might think that it starts with a T, but like so many elements, it doesn't start with the letter that starts the English name of it. Tungsten, the symbol is W. The tungsten ion is W6+, number 74 on your periodic table. And so when we write tungsten oxide, our cation is going to be W6+. Zoom out a little bit, sorry. Cation is going to be W6+, and our anion is going to be O2-. You might be tempted to do the little switch thing, but then you'll get something that's not the simplest possible compound. Instead, think about what's the lowest common multiple between 6 and 2. Well, if we multiply 6 by 1, we get a 6 positive charge. And if we multiply 2 by 3, if we have 3 oxides, then we would get a 6 negative charge. Each oxide brings 2 negative charges, and each tungsten brings 6 positive charges. So when we write our balanced ionic compound, we only need 1 tungsten and 3 oxides in order to get a net 0 charge. And I'm just going to put this little S after here to show that tungsten oxide would be a solid because it's an ionic compound. This has been naming ionic compounds and writing the formulas for ionic compounds for binary compounds. These are for compounds where there is only one possible cation for this name and one possible anion for this name. In the next lesson, we're going to talk about naming ionic compounds for some of the metals that have more than one charge.